So what do you do once you have a script written? How do you write it and how do you run it? Well, so to successfully write a script, you have to do three things. First, you have to write the script, obviously. But then you have to give shell permissions to execute it, okay? So typically, guys, what this means is that you need to give it executable permissions in order to execute it, okay? You have to also keep in mind that if you want other people to run it, you might have to set executable permissions for them, okay? So a safe bet is to just give all executable permissions, but sometimes you may not want to give everyone executable permissions. So you have to do a little bit of thinking before you decide which executions to give to run those scripts, okay? And you also have to put it somewhere the shell can find it. So wherever that script is, you can't just say, hey, run this script if it's in a different directory, right? So you have to supply the full path if you're going to execute a script that's in a different directory. We're also going to talk about debugging. So -x option to debug a shell script. You use that -x option to debug a shell script. So when you run a shell script with the -x option, you can do bash-x in the script name, such as domains.sh. I'll show you that real quick just to show you what it does. So I have a pretty simple script written up here. Let me log in. Alright, so I have a test.sh script. I'm just going to show you what's in it. Oops. I need to spell it right. There we go. Okay, so pretty simple script. I have 3 variables set up here. So the script is basically just saying, hey, if A is greater than B, echo high, else echo by. Okay. In this case, A, 10, is obviously not greater than B, so it's going to echo by. Pretty simple script. Okay. So I would need to make that executable for all, right? Okay. And then I would need to run it. And I can add the -x option. You're going to see something interesting happen, okay? So it's actually showing you what's going on in each line. So it interpreted these 3 variables. And then it showed you on that if line, it said, hey, we threw in the variables here, so 10 greater than 20. And then it's showing you that it said, hey, we went to echo by, we went to that part, the else part, because 10 is obviously not greater than 20. And then by was echoed, right? So the -x option allows you to see what the script's doing. And this is helpful because you can see maybe where it went wrong. Like, oh, maybe 10 wasn't the right variable that was supposed to be input. Maybe I was supposed to input C instead, right? So that's why debugging can be useful. Let's go ahead and talk about data types. So unlike many other programming languages, Bash does not segregate its variables by type. Essentially, Bash variables are character strings. But depending on context, Bash permits arithmetic operations and comparisons on variables. The determining factor is whether the value of a variable contains only digits. So guys, when we say string, that just means, characters, right? So if I type in 10 or I type in 10, if I encapsulate both of those in parentheses, they both are a string and they just mean 10, okay? But 10 can also be the digit 10. So untyped variables are both a blessing and curse. They provide more flexibility in scripting and make it easier to grind out lines of code and give you enough rope to hang yourself. However, they likewise permit subtle errors to creep in and encourage sloppy programming habits. So Bash is a little flexible with how you submit variables and strings, but don't get trapped into that. Make sure you're using good programming practices. You always want to define variables, use quotation marks, even if you don't have to. So to use a variable is a character string to which we assign a value. The value assigned can be a number, text, file name, device, or any type of data. A variable is nothing more than a pointer to the actual data, meaning that a variable just holds a value. It's just a placeholder. The shell enables you to create, assign, and delete variables. The typeset command. So typeset and declare are exactly the same. The only difference is the typeset is considered obsolete. Okay? So when we say declare a variable, let's say I have a variable called a. If I do a equals 10, I am declaring that a variable equals the number 10. Here we have the typeset command, which is obsolete. So just be familiar with how it runs, but also know that it's not really used anymore. So we have typeset, a number of options here, -p, and then the name of the variable, and then the value of the variable. So it sets variable values and attributes, and just as we said, this is an obsolete method. And if you check the man page, it even lists it at the same time. So declare options -p name value of it, typeset options -p name and value of the variable. And this declares the variables and or gives them attributes. So not used anymore, but we want you to be aware of it in case you run into it in a script and you're curious as to what that is. So typeset is actually portable to some other shells though, for example KShell 93. If you're aiming for cross-shell portability, you might actually want to use typeset. If you don't care about such portability, you can just use declare, okay? So it might still be a good idea to use typeset just because it allows your script to be a little bit more versatile across multiple shell environments. Let's go ahead and talk about constants. So read only prevents subsequent changes in the value of any of the name arguments parameters of the form. So we have a variable name and then we have the value of it. We can assign the value to the corn shell variable name as well as marking name read only. If read only is called without arguments, it lists with appropriate quoting. The corn shell variables are set as read only. The following format is used. So if we do a variable and we set it equal to a value and we put it in parentheses, this is going to be suitable for reading by a shell script, but to ensure the portability of the read-only access, the -p option should be used. Okay, so when we encapsulate the value here, okay, this allows it to be portable. If we don't, it's going to set it as read-only. We also have special predefined variables. So to create a variable, you just provide a name and a value for it, as we've seen several times. So I can do variable named a, so I can do a equals 10, and that's setting a variable a equal to the number 10. So your variable name should be descriptive and remind you of the value they hold. So obviously a variable named a isn't very descriptive, so a variable name cannot start with a number, nor can it contain spaces. It can, however, start with an underscore. To read the variable, we then place its name preceded by a $sign anywhere in the script we would like. Before Bash interprets or runs every line of our script, it first checks to see if any variable names are present. For every variable it is identified, it replaces the variable name with the value. That's simply how we call the variable. Okay, it sees the $sign and knows, hey, this is a variable. Let me see what that is being stored in that variable. So $1 is the first command line argument passed to the shell script, also known as positional parameters. $0 is the name of the script itself. $1 is the first argument, $2 is the second argument, and so on. Okay, so guys, these are special predefined variables. All right, I can't name a variable 1 or 2 or 0, okay, because those are reserved as special variables. So when I pass an argument to a script, the first argument goes to $1, stores it in that variable. The second argument gets stored in $2, and so on. Okay, and as it said here, $0 is the name of the script itself.